Okay, in this second test review video, we're going to look at some Chapter 4 items and a Chapter 5 question. So just to go through this, in number 1 it says the scatter plot below shows the age of a book club's members and the total number of books they've read in their lifetimes. First question, would calculating a correlation coefficient and finding a regression line be appropriate for the scatter plot below? Why or why not? Across the bottom here, this would be the ages, and across this vertical axis, this would be the number of books. Based off of my two variables, age, total number of books, 15, 16, 17, 18, and 19, those make sense as ages. 200, 250, 300, 350, those don't make sense as ages. So age is my explanatory variable. Number of books is my response variable. I would use the age to predict the number of books. If I look at the scatter plot, there does seem to be a fairly linear pattern. So I could say calculating a correlation coefficient, that's R, and finding a regression line to describe this data would be appropriate, and that's because the scatter plot appears to be linear. There's no clear curve with these data values. The second question, what range of values would be appropriate for making predictions? Why? The values that would make sense, that are appropriate, are the ages 15 to 19, because that's what we've observed with this particular book club. Anything else outside of that will be extrapolation and may not be as accurate. We can't make a prediction for a 20-year-old or a 22-year-old or a 30-year-old. As well, we can't make a prediction for a 7-year-old or a 6-year-old based off of this data. Extrapolation is a key word from Chapter 4. Number 2 is going to be a calculator question from Chapter 4. This table shows the number of hits and the number of home runs for 10 randomly selected players from a minor league baseball division. We want to complete each part. So part A asks us to find the correlation coefficient, that's R, for this data set. And I want to know what information does R provide in this case. Well, to find R, you need your calculator. I need to get this data in, so I would hit Stat and then Enter to edit. And to save some time, I've already put the data in here. I've got my hits, my X in L1. I've got my home runs, my Y in L2. To make my calculation, go to Stat, Calc, and number 8. Hit Enter, and I can see my R value is 0.79. That is my correlation coefficient. Say this relationship is positive and it's strong. R is above 0.74. Also note that R is appropriate because if you view the scatter plot, it is linear. To view your scatter plot, you just hit Zoom and 9. I don't see a clear curve, but fairly linear correlation here. So R is appropriate in this case. If I did see a clear curve, if I had some dots starting to trail off down here so it made this shape, then R would not be appropriate. But because R is over 0.74, we can say it's positive and strong. Recall that if R is 0.75 to 1, either positive or negative, it's strong. If R is 0.50 to 0.74, positive or negative, it's moderate. And if R is anything 0.49 and below, it is very weak. In part B, we want to find the regression line that describes this association between hits and home runs and interpret the slope and the y-intercept. We've done that already. It's just under Stat, Calc, number 8. The regression line is in the form y equals a plus bx. My a is negative 21.597. Out of that to negative 21.6. My b is 0.3, so it's 0.3x. My slope interpretation is 0.3. The The slope is a prediction for y, which in this case is home runs, as the x goes up by 1. So I could say we predict home runs will increase by 0.3 as the hits, the x, increase by 1. The y-intercept is our prediction for y, or home runs, when x is 0, or when hits is 0. So it says we predict negative 21.6 home runs for someone with 0 hits. That doesn't make any sense. If you have 0 hits, you should have 0 home runs. You can't have a negative number of home runs. This would be an extrapolation. The lowest number of hits we observe is 109. The highest number of hits we observe is 207. Anything in between these should be fairly accurate. It's when we get outside of those values that we have extrapolation. Final part here, make a prediction for the number of home runs for a player with 180 hits. I would just plug 180 into my linear regression equation. My calculator can say negative 21.6 plus 0.3 times 180. Our result is 32.4 home runs. Should be fairly accurate. If you have 180 hits, you should have around 32 home runs. It's not a guarantee, but it should be fairly accurate. It's not an extrapolation. This pretty much covers everything from Chapter 4. The only thing that we didn't discuss was the coefficient of determination. That's your R squared. In this case, it is 0.625 or 62.5%. We could say 62.5% of the variation in home runs is explained by hits. 62.5% of the variation in home runs is explained by hits. Final question in this video. We've already seen a problem just like this in another video, but to go through it one more time, it is important for this next test. Consider rolling 2 fair dice and adding the outcomes. What is the probability the sum is 9? When we rolled these dice and added the outcomes, we made this addition table. Here's the first die. You can get 1 through 6. Here's the second die, also 1 through 6. And then you just add the results. So 1 and 1 was 2. Here, 3 and 4 gave us 7. When I filled this table in, there are a total of 4 9s along this diagonal. There are 36 total possibilities here. You could count all of these up to get your 36, or you could say this 6 times this 6 gives you the 36 total. So 4 divided by 11 as a decimal is 0.1111. The preferred method on the test will be to give your answer as a decimal.